Hey, Algebra 2. Welcome to the second week of our in-home learning. Today, we're going to start what I would consider one of the harder parts of Algebra 2, maybe even the hardest. Because at first, the concept of it is kind of difficult to understand. But hopefully with this YouTube videos, and we'll go especially slow in case if we don't get it. We'll spend 2 days per lesson. We'll be able to get through this. So I think it's not going to be too bad. Um, and maybe it's a benefit that we do this at home because now you could take your time and there's no 40-minute limit. I just do the YouTube video, I'll do practices, I'll do Zooms to help out in this. But it's doable. It's very doable. But the concept's a little different and a little bit weird, but we'll get through it. All right. Now, 4.4, evaluating logs. Now, if you have any friends or in any other math class, they should have already done logs, and they might have already complained to you what logs are. But before we even start about what logs are, let's just talk about something. Let's say if we have the square root of 9 equals 3. Well, that statement is true. The square root of 9 does equal 3. What if I squared both sides? So let's say I put a square here and a square here. Well, this cancels out, and it becomes 9 equals 3 squared. So you see how the top statement was true, square root of 9 equals 3, and the bottom statement is true, 9 equals 3 squared. Both statements are true at the same time. So square and square rooting are opposite operations. Like they're going against each other, Square and square rooting is opposite operations. So we need something that is the opposite operation of this. It's very strange to say, but let me see if I can explain it as best as I can. Let's say 3 to the x power equals 9. Now, I know most of you are smart enough to say, oh, Mr. Tobel, that's 2. 3 to the second power is 9. I know some of you made a mistake and said 3, but no, it's 2. 3 to the second power is 9. All right. I need a way to rewrite it so I could have x by itself. So what I do is I move the base of the exponent. But when I move a base of an exponent, I need to put a log. Because now I'm logging in the base. So I'm logging in the base. So now it's going to become x equals log. We're going to put a little 3 here because it was a log base 3. Because this was a 3. Big 9. So when you change a base of an exponent, you have to log it in as a base of 3. So there's a 3, it's a base of 3. So x equals log base 3, 9. So what does log base 3, 9 is asking? What log base 3, 9 asks is what variable, and maybe I'll write this down, what variable, I'm sorry, not variable, what number 3 to some power gives you 9. And you guys are smart enough to tell me that x should equal 2 in this case. All right? So what's happening here is that we're just trying to figure out how to rewrite something like this question into something where we could get x by itself. So let's do another one. Let's say, what is log base 4 to 64? So first, I want to practice. How do you word this question? What I'm asking in this situation is 4 to what power gives me 64? 4 to what power gives me 64? Well, that happens to be 3. So 4 to the third power equals 64. All right, let's try another one. How do you set up this? Log base 2 gives me 8. So what does that mean? Well, 2 to some power gives me 8. So 2 to some power gives me 8. What is the power? Happens to also be 3. So you're looking at me and you're like, well, Mr. Toba, that's pretty obvious. 2 to the third power equals 8. Or maybe you're saying, like, why waste your time writing it like that if you could write it like this? Which is a very good question. It's a very good question. Now, there's some situations like, let's do this one. Log base 2, let's say to 7. So I'm going to rewrite that as an exponent. 2 to the question mark equals 7. Now, do you know what 2 to what power gives you 7? No. Do I know what power 2 to the what power gives me 7? No, I don't know either. So what I'm using is this right here to help me figure out what that question mark is. Sometimes they're obvious. Sometimes 2 to what power gives you 8? Well, that's just 3. 2 times 2 times 2. Sometimes they're obvious. What is this one? 3 to what power gives me 9? Well, 3 to the second power gives me 9. But most of the times, let's say if I pick 2 random numbers, they're not always going to be perfect or clean. And that's why we end up using the logs. So now the next part is going to be practicing rewriting logs and how to put it in our calculator. Okay, so I would ask you in these type of questions to rewrite in exponential form. So in the previous part of the video, I put a question mark. Now we have actual numbers. So how do we do that? Well, what I'm going to do, this is a log base 3. This is a log base 3. So when I turn it to here, it becomes exponent base 3. So it becomes exponent base 3, all right? So log base 3, 81 equals 4. So this will become 81 is by itself equals, think of it as if a 3 goes like right underneath it. So 3 goes right underneath log base 3. 3 has to go right underneath 4, and not like a divide underneath, kind of like a base of an exponent. So this is a normal size 3, and it bumps the 4 up to an exponent. So we take the number here and move it to become the base of the exponent. So 81 equals 3 to the 4th power. Let's go to the next one. Log 14 1 equals 0. So let's go to the next one. Log base 14 1 equals 0. All right, same move. I move the 14 over here, and it becomes the base of an exponent. So 1 equals 14 to the 0 power. And that makes sense. 14 to the 0 power equals 1. Anything to the 0 power equals 1. So that's really good for us. So that checks out. And that checks out. I should have said that checked out for me before. Let's do one more. I'm going to make this up, so hopefully I don't mess up. Log base 3 to 27 equals 3. So I take the base of the log, and it becomes the base of the exponent. So it becomes 3. So this 3 here is this 3 here to the 3rd power. So that's how our base of logs works. They're just simply the reverse of the base of the exponent. So when I ask you to rewrite it, you just take whatever number's on the bottom here, and you move it underneath the other number and make the other number an exponent. So here it was a 3, it became 3 to the 4th power. Here was a 0, it became 14 to the 0 power. Here was a 3, so it was a 3 to the 3 power. Maybe this one kind of sucks because we use the same number. I'll keep that in mind in the future. Okay, so that's how you rewrite logs into exponents. So now what we're going to do is practice how do we find the answer for a log without a calculator. All right, so let's do this type of problem. Log base 15 to the 15. Well, what the? They're the same number. That's going to be important. So your question is just going to look like this. They're going to give you a log with a base and a log with a number. So how do we solve this? Well, what we're first going to do is set it equal to x. Okay? So step 1, and I'll type this into the Google Post. set equal to x, or whatever variable. Step 2, move the base of the log to become the base of the exponent. So 15 equals 15 to the x power. This 15 moved over here, and I'm just underlining it. This is not a fraction line. I'm just underlining it to show. All right. Step 3, figure out what x should be in order to get your answer. So let's think about it. 15 to blank power equals 15. So what would it be? Well, I should remember this exponent rule. Any number to the 1 power is the same. So what would x have to be in this case? 1. So x equals 1. Let's try another one. Log, let's see, 6, 1 over 6. Oh no, there's a fraction. Okay, but don't worry, we can handle that. All right, log base 6, 1 over 6. So let's set it equal to x. All right, so step 1, set it equal to x. Did it. Step 2, move the base of the log to become the base of the exponent. So that's 1 over 6 equals 6 to the x power. Now I have to think, what is 6 to what power gets me 1 over 6? Now this is strange, right? Usually our numbers get bigger. Think about it for 3 seconds. What exponent can you put to make it a What exponent can you put in to make it a fraction? What exponent could you put it in to make it flip down? And I might have slipped up a little bit. Well, if you didn't catch the slip up and you got it all by yourself, it's a negative exponent. So what negative? It's 1 over 6. So let's think about it. If I made this a negative 1, this will get flipped over to, this would be 6 to the negative 1. So this becomes 6 to the 1 over 6 to the positive 1. And look at that. At that point, it matches. So that means x equals negative 1 in that case, because that's the exponent that would make 6 into 1 over 6. Let's do log. Let's see, what's a good one? Oh, 12, 1. So log base 12 to 1. So step 1, set it equal to x. Step 2, move the base of the log to become the base of the exponent on the other side. So 12 to the x power. Now I have to ask myself, 12 to the x power, what do I do to get 12 to the x power to equal 1? Well, now I have to remember another exponent rule. It's that 12, anything to the 0 power, so even a million to the 0 power becomes 1. So anything to the 0 power becomes 1. So x has to be, in this case, 0. Because 12 to the 0 power does become 1. So that works out. So x equals 0 in this case. All right, I'm trying to think if there's any other one. Let's see. So I want to tell you this. If you see that log something equals 1 here, you could automatically say x equals 0. As soon as you see log base whatever equals 1, you could say x equals 0 at that point, because it becomes a 1. And that's going to be more important later when we do some other things. But as of right now, I'm just trying to tell you what is a log and how to do a log. Okay. One more. I don't think I gave you a fraction in the base, so let's try that. So let's do log base 1/2. So the base is a fraction. That's okay. A base could be a fraction. To, let's say, 4. Okay. Step 1, set it equal to x. Step 2, take the base of the fraction, base of the log, which is 1/2, and make it the base of the exponent. So 4 equals 1/2 to the x. Base of the exponent of the other side, I should say. Okay, 4 equals 1/2 x. Oh man, so what are we going to do? 2 is on the bottom, and we're not happy about that. So we got to think about, how do we make 2 go to the top? We got to figure out a way to make 2 go to the top. What type of exponent makes a number moves up or down? A negative exponent. So then let's start working out like this. So 4, I know my exponent has to be negative. So I'm going to put 2 to the negative x. Okay? So I wrote it as 2 to the negative x, because I know my answer is going to have a negative, so I write the negative there. Now, let's think about it. 2 to the negative x. So what number for my exponent, if I cover up the negative, will get me 4? So what number for my exponent 2 gets me the number 4? Well, 2 to the second power gives me 4. So 2 to the second power does give me 4. So my final answer is x equals -2. Because the negative here and the 2 here. So x equals -2. All right, I think earlier in the video I said we're going to do by calculator. I'm going to save that for either tomorrow or the day after. Tomorrow's lesson will be just more 4.4, a second part. But what's really important is to understand the log stuff. So I'm going to ask you, part of your homework is also to private comment me. Did you feel like you understood this? Would you like me to do this again? Whether yes or no. So part of your homework not only is going to be the homework page I attach, but for you guys to tell me, what do you think about this lesson? All right? Have a wonderful day. We made the schedule a little bit easier so you guys could handle it. It's also a little easier for us as teachers, and hopefully it allows us to have a little bit more Zoom sessions. So I don't think I will have a Zoom session today. Maybe a Zoom session tomorrow after I do the second part of 4.4. Or the next time we meet, either tomorrow or Thursday, I'm not sure. All right, have a wonderful week, guys.